Ever pondered how high you could jump on a different planet? It's an intriguing thought. To grasp this, we must explore the science of gravity. Gravity is the force that draws us towards Earth's center. It's an unseen bond that keeps us grounded, maintaining order in our world. It's the we fall back down after a jump, but what if we jump somewhere else in the universe? The tantalizing aspect of gravity is that it presents itself differently depending on the planet you happen to be standing on. On our home planet Earth, the gravity has a unique characteristic. It is crafted to perfection, ideally suited just for us. It is calibrated to a degree that's not so overpowering that it crushes us, nor so mild that we just drift off into the endless expanse of space. However, the intriguing question is, what if we were to take that leap, not on Earth but on a different planet, say Mars or Jupiter? The implications are fascinating to ponder. Things start to take an exciting turn and the scenario becomes nothing short of extraordinary. Consider Mars, for instance. On this red planet, the gravity is a mere shadow of what it is on Earth. It amounts to only about 38% of Earth's gravity. To understand how that changes things, imagine jumping on Earth. On average, a person can jump about 3 feet high on Earth. Now consider the same leap on Mars. With Mars' weaker gravity, this leap would catapult you nearly 8 feet into the air. To put it into perspective, that's almost 3 feet higher than a standard basketball hoop. Suddenly you are not just jumping, you are soaring. In essence, that simple act of jumping is transformed into an exhilarating experience of semi-flight. So, if you can jump about 3 feet high on Earth, on Mars, that jump would take you nearly 8 feet into the air. That is indeed taller than a basketball hoop. Now let's take a moment to embark on an adventure we've never undertaken before. A giant leap to the immense and awe-inspiring world of Jupiter. Jupiter, the largest planet in our solar system, often too as a gas giant, is not for the faint-hearted. It's a world where the laws of physics as we know them on Earth appear to be completely rewritten, and one such law is gravity. On this colossal gas giant, gravity is not just slightly, but a staggering 2.5 times stronger than it is on the surface of our home planet Earth. This means that the seemingly simple actions we take for granted on Earth can become difficult tasks on Jupiter. Imagine, for instance, a 3-foot leap, a simple hop, skip, or jump that you might take in your backyard on a sunny afternoon. How would that translate on Jupiter? On this seemingly simple accomplishment would drastically change. That 3-foot leap you took on Earth? On Jupiter, it would barely lift you off the ground. A humbling thought indeed, reminding us of the vast differences in the universe that surrounds us. In the grand scheme of the cosmos, our ability to jump is shaped by the gravitational pull of the planet we're on. The weight of the planet has a direct impact on the strength of its gravity, and as a result, it directly affects our capability to jump. For instance, the heavier the planet, the stronger its gravity. Consequently, the stronger the gravitational force, the less we're able to jump. It's an inverse relationship. As the gravitational force rises, our jumping capacity diminishes. Now let's explore the other side of the scale. In contrast, the lighter the planet, its gravitational pull is. Thus, the weaker the gravity, the higher we can leap. This is because the force that pulls us back to the planet's surface is relatively weaker, allowing us to break free from it more easily and leap higher into the air. It's fascinating to realize that our jumping prowess isn't solely dependent on our physical strength. It's not just about our leg muscles or our athletic abilities, rather, it's also about where we find ourselves in the universe. Our location within the vast cosmic expanse plays a crucial role in our ability to leap. Here on Earth, you're bound by our planet's unique gravity. Earth's gravity is neither extremely strong nor exceptionally weak. It's just the right amount to keep us grounded yet still us to jump. However, the story changes when we consider the vast expanse of space on other planets. The gravity on these celestial bodies varies significantly. On some, you could leap tall buildings in a single bound, almost like a superhero, due to significantly reduced gravitational pull. On others, you might struggle immensely to even lift your feet off the ground because of the incredibly strong gravitational pull. So, in essence, our ability to jump, or lack thereof, is all a matter of gravity. Isn't it fascinating how a simple act like jumping becomes so complex when we introduce the variable of gravity? This ubiquitous and yet elusive concept, gravity, manages to turn the most mundane of actions into a marvel of physics. Just imagine for a moment the act of jumping. On the surface, it seems straightforward enough. You bend your knees, push off the ground, and for a brief, exhilarating moment, you are airborne. But when we delve deeper into the mechanics' seemingly simple act, the complexity begins to unfold. We live on Earth, which means we're accustomed to its specific gravitational pull. Yet the universe is not one size fits all when it comes to gravity. Take Mars, for instance. On its rusty, wind-swept plains, your jump would carry you far higher than on Earth, due to a gravitational pull that's merely 1/3 of ours. Then there's Jupiter, a gas giant with a gravitational force 24.79 times that of Earth. Here, an attempt might leave you feeling as if you were glued to the ground. Exploring these celestial bodies offers a tantalizing glimpse into the ways gravity shapes our universe, twisting, turning, and bending the fabric of space-time itself. It brings home the stark reality of our existence in this grand cosmic theater, where each planet, star, and galaxy dances to the tune of gravity's unseen hand. It's a reminder that we are part of a much larger, ever-changing universe, bound not only by gravity but by the endless possibilities of the cosmos. So, the next time you bravely venture into the unknown, whether it's a modest step or a monumental leap of faith, bear in mind the unseen but ever-present components at work. Keep in mind the silent, invisible forces that shape your trajectory. Consider the grip of gravity, that ceaseless pull that tethers us to contemplate its unfaltering power, the grounding presence that makes your leap possible. Reflect upon the physical laws that govern our world, and how they play a role in each and every jump or fall, whether big or small. And remember, somewhere out there in the vast expanse of the cosmos, that jump could have a drastically different outcome.